Hi, my name's Dan, and I'm going to be spending a little bit of time talking today about deep learning in practice and some of the trends or patterns that we're starting to see emerge around what I consider to be a very novel technology. You know, the tempting analogy is that deep learning is just a logical extension or sort of a natural evolution of big data or analytics or classical machine learning methods. And that the pipeline and the way we develop this technology will remain, for the most part, the same. And I'm going to be making the case today that maybe that isn't so obvious, and that there's actually a much more useful analogy to help us understand what deep learning in practice will look like as it matures. First, just a couple words about my company, Paperspace. For some context, for anyone who's not familiar, we're a serverless AI platform built for developers. So really quickly, what do we do? Paperspace is a platform where companies develop and train deep learning models. There are kind of two primary pieces involved to that, the first of which is infrastructure automation. So as you're probably familiar, one of the biggest bottlenecks in sort of the adoption of deep learning today is infrastructure. And so the way we think about eliminating that particular bottleneck is by transforming infrastructure into code. So practically speaking, what that means is we provide an environment where a developer can safely make the assumption that infrastructure is homogeneous. And sort of behind the scenes, what we're doing is unifying disparate compute architectures into a single command line argument. So that could include an NVIDIA DGX2 or a Google TPU or a new ASIC that you're testing. And those can be plugged in so that developers can effortlessly stretch workloads across clouds and even into on-prem data centers. And then there's a software layer on top that we provide that I'll discuss a little bit more in a bit. But essentially that includes things like graphing and collaboration tools and model versioning and support for tools like Git and Jupyter and so forth. Just imagine having a piece of software that's sort of like GitHub for machine learning. That's kind of one way we think about it. One of the things that stands out about this industry is the audience. Sometimes our customers refer to themselves as data scientists. Other times it's AI engineers or even deep learning practitioners we hear pretty often. But ultimately, what this signifies for us is that with deep learning, you have this entirely new class of users that came about that's growing at a pretty obscene rate. And then there's also this new compute constraint. And by that I mean GPUs and other accelerators that just didn't exist previously with old methods that you now have to contend with. And for us, this combination of factors posed a really interesting opportunity for us to take a step back and rethink how this new class of users should interact with the cloud, these new chips, and what tools they should be using. And here's why that matters. From talking to people in industry, we've noticed a pretty alarming trend. AI developers spend very roughly 3/4 of their time thinking about infrastructure and about 1/4 of their time actually doing the thing that they were sort of brought on to do. And these are some of the most sought-after people in the tech industry. In fact, well, any industry for that matter. And very little of their time is actually just spent developing models. It's an inefficiency of sort of epic proportions. So what's the underlying problem here? It really comes down to one thing. The cloud is sort of the perfect place to run these kinds of workloads, but the cloud as we know it today was really built for the singular use case of deploying and managing web servers. And cloud products are really built for DevOps, and DevOps, as an audience, has almost nothing to do with deep learning practitioners. Ultimately, what this means in practice today is that if you want to invest in this technology, you have to make a really substantial upfront investment in DevOps and tooling just to, before you can see any results, effectively. Now, this stands in kind of stark contrast with traditional software development, where the ecosystem is very rich and mature. On top of the public cloud, you have thousands of tools that developers can plug into, tools like GitHub and CircleCI and New Relic that essentially abstract raw infrastructure into something that development teams can kind of plug into and operationalize. And these tools are so essential that modern web application development would be almost impossible without them. The thing that is obviously missing from this picture is the equivalent for AI developers. Now, we obviously spend a lot of time thinking about this and have found that the key to solving this problem is sort of finding the right layer of abstraction. And getting this right is really tricky. On the one hand, on the one extreme, you have these like kind of toy projects where you can tinker with a neural network in a browser, and these tools are often severely limiting. And on the total opposite end of the spectrum, you have very powerful yet complex low-level libraries like Kubernetes, where I tend to think of those tools as really being in the role of DevOps and not in the wheelhouse of a developer. So finding that right layer of abstraction is really important so that developers can be productive. Another really interesting sort of evolution that we've picked up on in sort of modern ML in practice is that this sort of, in the last couple of years, there's been this transition from a few years ago where people were sort of obsessed with this idea that everything would be an API. So you have the image recognition API, the NLP API, the recommender system, the churn prediction API. And this is an example of trying to shove deep learning into a web services model. And there are many obvious limitations to this, and the result is that it's not really broadly viable sort of in practice. Then a few years later, everyone thought we could just refit models to existing pre-trained models. But just like the generic API, if your problem statement will always differ from the sort of intent of the original model. And the trade-off there is, of course, just a lower level of accuracy. And because of this dilemma, this has not proven to be a viable strategy. But this is not a bad thing. What people are realizing is that since AI is so core to what they do and is so valuable, that they actually benefit from owning the model. And the model becomes sort of core IP in a very powerful way. And these companies are now hiring AI developers to develop their own proprietary models. And that's kind of the trend that we're seeing today. So of course, if that is the case, then you're sort of building out your own pipeline. And put together this slide to kind of do a diagram of like what a kind of canonical pipeline looks like today. So this is kind of zooming out. You have on the left-hand side a data source. So you have either a data lake or a streaming data source coming in. And then from there, you're going to create like a feature store of training data, which is essentially just pre-processed data ready to be fed into a framework like TensorFlow or PyTorch. From there, you develop and train models iteratively and in parallel, and then ultimately evaluate the results of that model. And then sort of the last step at the end is deployment. And deployment can take a number of different forms, either as an internal batch prediction service or as a public-facing RESTful microservice or even a component within an iPhone. So going back to this idea of finding the right analogy for deep learning, we came up with what we call CI/CD for machine learning. For those of you familiar, CI/CD, continuous integration, continuous deployment, kind of lives at the core of most modern web applications. So if you think about the pipeline just outlined previously, it obviously closely resembles a standard CI/CD pipeline in a lot of interesting ways. So basically, they both take an output, or sorry, they both take an input, then some operation is performed, and then ultimately the output becomes available to hit with a request of some kind. And if you simply kind of swap these out, you can see how close or how similar they are to each other. So our product called Gradient is our take on CI/CD for machine learning and AI systems. As a platform, it is designed to take a set of core building blocks, and which can be composed into a larger and more complex system. Formalizing the pipeline not only simplifies the workflow, increases developer velocity, time to onboard, things like that, but it also breaks bad habits. And what I mean by that is the ridiculously high percentage of AI development that's still happening on desktop computers today. Or if the cloud is being leveraged, it's often a developer just SSHing into a box in the cloud. So ideally, just like a software engineer, an AI engineer can write code locally in the IDE of their choice, push that code in a Docker container to the cloud, which kicks off some automated steps that are reproducible and deterministic. As an example of the kind of way we think about this, we're working on a GitHub bot right now that will basically start training a model with a simple git commit. So this is just a really quick snapshot of what this looks like in practice. At a high level, you have the basic pipeline components of data ingest, training, analysis, and deployment. And so our tool Gradient provides a unified dev environment through a command line interface and UI, which is a centralized kind of hub to view your jobs and the metadata associated with those jobs. So that would include things like graphing of accuracy and loss, and things like the device that it was trained on and the container that was used and the framework and version of the framework that were used, how long it took to train, that kind of thing. And sort of as best practices emerge, we formalize them in gradients. So some examples of that include containers becoming a standard today, first-class support for Jupyter, as well as in addition to our CLI, we now have a full Python language integration. So in a nutshell, I guess our goal is to make CloudML as easy as building a modern web service. Obviously, there are a lot of different ways to kind of approach this, but we believe that this CI/CD model is a really valuable way to kind of conceptualize the process of doing modern deep learning in production and at scale. The last thing that this paradigm kind of offers is something that a lot of people in the industry view as like the holy grail of machine learning. And by that I mean this sort of real-time online learning systems that are just now coming about. So fast forward a few years ahead, what does deep learning look like in practice? What we're most interested in is sort of these online predictive engines that actually continuously update as more data becomes available. To be clear, very few organizations are actually doing this today, but it's clearly on the horizon and something that is actively being worked on. It goes without saying that no one really understands exactly what that's going to look like or what online learning will look like in the future, but what we do know is that it's an incredibly exciting possibility that happens just to fit really nicely with the CI/CD model. So with that, I'm going to wrap. Thanks for listening. Happy to geek out with anyone here. And if you'd like to connect, you can reach me directly at daniel@paperspace.com. Thanks much.